Hello friends, this time with audio. How is that? Yes. Alright, let's pretend this never happened. Hello friends of .NET, I'm Olendriver. You can find me on Twitter at TerraJobs. Okay, so today we want to continue our journey from last time, which is the concept of trivia. So last time we added the ability for our parser to handle comments. But the problem was that we don't actually have time to record them in the syntax tree. And so today what I want to do is I want to add them into the syntax tree so that later phases can actually use that information. And so for the most part, we don't care about white spaces and skip tokens and all the other stuff that is normally not relevant for the parser, right? But if you want to do things like code comments above functions become part of the, let's say, the IntelliSense description of the functions, we clearly want to somehow be able to parse those, or at least expose them somehow. And the way Roslyn does it is they have this concept of trivia, which is basically all the stuff that is normally not relevant for the language semantics. They're still in the syntax tree that you can access. And the trick here is to make it so that you can record them in a convenient fashion that don't complicate the parse tree or the syntax tree significantly. And they also don't make traversal of the syntax tree super complicated, unless you actually care about these things. But having all this information, the syntax tree does a few things for us. One, we can actually say the syntax tree is the entire representation of the input file, which means you don't need anything else. You don't need to, somehow substring part of the input file later, right? The other thing is that if you express things like refactorings as modifications of the syntax tree, then it's kind of clear why you want whitespace and comments in this tree, because even though they're not relevant for the language, they're highly relevant for the developer, right? We wouldn't appreciate if, let's say, we do a refactoring, like a rename, and all of a sudden whitespace and comments would entirely disappear, right? So that means we need to somehow record that. I guess audio is trivia too. Fun one. Yeah, I just had some trouble with my setup, so I rebooted my machine, and I already checked the audio, but yeah, but apparently I didn't do it after I rebooted, so audio was gone when I actually finally started to stream. All right, let's just jump in. So what do we have here? So let me jump to the PRs first. How's your day so far? Hopefully it's better than my day. Yesterday I had fun. I pulled an insider update that actually caused my start menu to stop working. And as you can imagine, a start menu that doesn't work is actually quite hard. And it was even worse. Not only start menu didn't work, also background tasks didn't work on Windows. VPN didn't work on Windows. So my productivity was fairly low. All right, so let's look at what we have. There's a bunch of things we have actually now. Holy cow. I guess I have to reserve more time to build 2 PRs now. So the compiler test one, I talked about it last time, I think. Updates to build infrastructure. That's one of those things that taking that earlier rather than later makes sense. What does this do? Interesting. Okay, this one I want to spend more time reviewing because otherwise I don't get anything done today. This one I think I already reviewed. Yeah, so we talked about this a few episodes ago when we did our string concatenation work. So the ways we do it right now is we basically have a function called string concat, which takes 2 arguments. And when you say a plus b plus c, we first call string.concat on a plus b, and then we call it on the result of a plus b and c, which now means we basically concatenate multiple strings. So if you do a plus c plus a plus b plus c plus d, we don't just create one string, we create multiple strings. That's not how C# does it. The way C# does it, it says, well, let's flatten the tree. So basically when you have this nested tree, they basically just grab the individual leaves out of it. And then they say, well, if there's 2 arguments, we call string concat. If there's 3, we call string concat with 3 arguments. If there's 4, we call it with 4, because that's how many overloads the framework has. And then we say, well, if there is more than that, we just create an array and call string concat on that one. And so that's still more efficient than actually doing it multiple times, right? And so what Lucas did is he basically just added the binding to these methods. And then when we emit a binary expression, we don't just emit left and right at the beginning. We just say, well, if it's one of those magic ones, then we call a dedicated method for this. And then otherwise we emit left and right and we continue as we used to. And then in this guy here, we basically say, well, let's first take this node, let's flatten it. So then we have the leaf nodes here. And then we just say, well, how many do we have? If we only have 1, well, then we just load the string. If we have, you might ask why we might have 0 or 1, but we come to that later. But if we have 2, then we could just call, we just emit left and right. We call in the string 2. Otherwise, we emit 3. We call the 3 one. For 4, we call the 4 one. And then the default one is basically, okay, we first emit a number of how many elements we have, and then we create the new array instruction that creates an array. And then we just emit opcodes to load that array, right? And the way we do it here is we basically do a duplicate, which basically first make sure that the array that we have currently on the stack, that the reference is effectively available. Then we load the element, we load the expression we want to store. We store the expression, and then this repeats. And then eventually we just call with the array reference. So that's fine. Then there was some issue with me not seeing this as a local function, but let's ignore that for a moment. So the flattening is pretty straightforward, right? You just do effectively a loop. He does it in a recursive fashion here, which is not uncommon, but it also has problems. So recursiveness so for example, the way C# does it is that for binary expressions in particular, they don't use recursion. Usually they have what they call a stack-guarded walk effectively. So basically they use an actual stack object to keep track of the nodes. And the reason they do that is because generated code, meaning code generated by some sort of like string builder that that generates C#, very often has very deeply nested binary expressions. And what ends up happening is if you have too deep of a nested tree, you stack overflow, right? And so the compiler tries to guard against that by saying, well, generally speaking, when we walk trees recursively, they effectively make sure that they don't stack overflow, but they basically keep track of how deep they are. And when a certain depth is exceeded, they just they just throw an exception effectively. And that's better than a stack overflow, because if one of your threads stack overflows, that means the process is done effectively, because you can't really recover from a stack overflow exception, because that means one of your threads is done. And if one of your threads is done, because you all have shared memory, God knows what state the process is in, right? So usually when you stack overflow, you should terminate the process. And in order to avoid terminating the entire process, which in the context of an IDE would mean you tear down all of Visual Studio, or at least whatever external process Visual Studio is using for hosting the compiler. And so what they do is they just flatten it, right? We don't do that because it's complicated. It's just a complication. And even though we pretend here that we're trying to build something rock solid, right? There we do take some liberties in order to not complicate the design entirely. But that's an interesting thing to keep in mind when you think about recursive walking of trees, is that recursiveness is not free, and stack usually is one of those resources that you don't have a lot of. Anyway, so that's basically the flattening part. So after he's done flattening it, meaning if you have a tree like this, basically you have A, B, and C, he applies constant folding. And constant folding we did last time, and normally we do constant folding is not by modifying the tree, but we are effectively having a constant expression on the, so yeah, a constant value on each expression, and the expressions effectively themselves do the constant folding. But the downside is we can only fold constants now if the tree shape allows us to do that, right? So for example, if A and B are constant, yes, then this node here has the folded constant that represents the concatenation of A plus B. But let's say what's actually constant is B and C, right? Then, but A is not. That means this node here cannot apply constant folding yet, because only this expression is constant. This node cannot do constant folding because this subchild here is not a constant. But if you think about it, A plus B plus C, well, I can of course fold constants B and C, right? But the tree shape doesn't allow us to do that. But in his case, because he just has the flattened representation here, he just sees them as consecutive members effectively in an array. And so his logic here takes care of that. Basically, he has a string builder, he walks through each node, and then he says, well, if the node has a constant value, well, then the question is, do we have a string builder? If not, we create one. And then you're effectively saying, okay, append the value. And so consecutive members are effectively collapsed. And then what actually remains in the list is only the things that are truly non-constants. And of course, when you apply constant folding now, that means you might actually create a list of one element, like a list that only has one element, right? I'm not entirely sure how you can ever get to 0 elements though. Oh yes, so the way you get to 0 elements is he skips things that are null or empty. So C# does it when you say A plus empty string, then it's effectively just A. Except that C# has this spin on it where it says, well, if A is null, then it's not just A, it's the empty string, right? Because if you do logically the concatenation of null and an empty string, you do get the empty string, not null, right? So, but yes, which is basically what he does here, right? He basically says if we have 0 elements, then we just load the empty string. All right, this is super awesome. Does that make sense to everybody? Propagate Lexa parser diagnostics through the binder. Yes, so that's one of the things we didn't do right now. So I already reviewed this. This is good. Basically, we changed the binder here to just say, well, the constructor should probably be private because we only have 2 entry points, really, the bind global scope and bind program. Bind global scope basically just takes all the syntax trees and creates the functions, the function declarations, and then bind program is walking each function and binds the function body. And so what he does here is he says, well, if we bind the global scope, we make sure that we append all the syntax diagnostics that we have to the binder diagnostics, so that we don't drop them on the floor. And then bind program says, well, if the global scope had any diagnostics, we add them as well. So this way we basically have, you know, each result set effectively accumulates the diagnostics. And then instead of doing this, we're basically saying if the global scope has any, we return this one. Otherwise, we evaluate. And then you just made this one an enumerable. That is good. Good stuff. Thank you. So it means this one is merged. This one is merged. Yes, so allow digits and underscores in identifier. So I think he said it here. It's like, I wanted to create a function in order to test my PR, but I was surprised the compiler doesn't allow that. Yes, so that's one of those things that, I don't know, it never came up before, but yeah, generally speaking, identifiers are not just letters, right? Usually the way it works is you allow a leading I mean, you require usually a non-number as a leading character, because otherwise it's ambiguous with numbers, or at least for the human, very, very much ambiguous. And so we basically would allow a leading underscore and a leading character, and then from there on, it's either another character, another underscore, or another number. And that's effectively what this PR is doing. Also a great change. Thanks, Lucas. Gonna do this one first. Yeah, this is me not being able to type things. Trivia, triva. Wow, unreachable warnings. All right, so let's talk about this one here. I don't think I've reviewed this one yet. Yeah, I need to review this one offline, but we see each other on Friday, right? So I stream twice a week now, so don't worry, these guys get merged. Same here. I also have not a chance reviewing this one. This one is also largish. We're already half an hour in, so I will defer this. So here's another link I would encourage you to visit. There's this event going on right now, which is called the Dev Around the Sun. If you haven't checked it out, they stream live on stream, I think, today as well. And the event is trying to raise money for the COVID-19 response, direct relief. I already donated yesterday, and if you have money that you would like to donate, that would be great for that cause, I think. So another call to action here. Try that. And then this one already pasted in the chat window. So there's this thing called livecoders.dev, which is a group of highly trained individuals who are streaming effectively on Twitch, but focusing on code rather than games. And so I tried to join this group of people, and it would really mean the world to me if you could comment on this issue and express your support. Let me comment this again here, so we have this one covered as well. All right, so then I think this is it for PRs today. Let me pull the stuff in that we just merged. And then it's time for us to do some coding again. I don't know about you, but cracking knuckles is one of those things that I'm now massively addicted to. It just feels so good. Also, every time I see the generators DLL now, I'm somewhat happy. It's so nice that we now have a place where we can add code to that we don't have to type by hand anymore. I'm not entirely sure why it takes so long to build. I think it's my CPU not being able to handle all of this, but hey. All right, let's talk about trivia. So, syntax node. Actually, this time, git checkout -b episode 24. I hope it's 24, if I counted correctly. All right, so we have our syntax nodes here, right? Our syntax node, there is it's basically the base type of everything that we have, nodes and tokens. And I guess we should start with our syntax token. And then what might also help is if I go over this PR again. Oh Jesus, dragging windows is hard work. I had not a PR. There was an issue here that has that in. So somebody asked how this actually works, and then I responded with it and said, here's what I would do. And so logically what we want is we want a thing called syntax trivia, which wouldn't derive from syntax node. It's just data that we stuff into the tree. And then effectively that thing also looks similar to a token in the sense that it has kind and text. And so this guy would basically be, whitespace comments and other stuff that we want to have. And then the way it would work is we would expose this as leading and trailing trivia. So the idea of leading and trailing is it's kind of where you want to put them, right? So if you consider like a source code snippet like here, the problem with whitespace and comments is they can be literally anywhere, right? So any place in the tree where you have two things, right? Just think of a binary operator, right? A plus B. Well, you can put comments after the B, before the B, after the, before the plus and then before the A, right? So there's like 5 places where you can put comments logically in the binary expression. So we don't want to have, properties for all of this in the syntax node. That would be ridiculous, right? A binary expression now has whitespace before. And that's just not super annoying. So the way Roslyn has done it is what I think exceedingly clever. So they basically said, well, first of all, we store them in the syntax node, in the syntax token. So each token effectively has its surrounding trivia, meaning before and after, stored in the token, which now means the tokens are still our leaves effectively in the syntax tree. And then the only spin they put on it is to say, well, a token, there's stuff before and there's after. So leading or trailing, right? So if you think of let here, well, this is leading to let, and this is trailing to X, right? What's now interesting though is you have comments that are on their own line. So the question is, where should this go? Is this trailing to X, or is this leading for brace, right? And the way they've done it is they said, well, leading trivia is everything before the token, including on previous lines, because that matches your mental model, right? If you put a comment in front of a function, that is not, or before a function, that's not usually a comment for the line before it, right? It's usually for the thing that you put it in front of. So that makes sense. Now then trading wouldn't exist at all, right? Why would you need trailing? Well, very often you do commenting like this, where you say, well, I put the comment after the thing I'm commenting. So basically trailing is everything that is still on the same line, but after the token. Right? So that means, logically speaking, this is the trailing trivia of A. It's not leading for this. So leading can only be for the first token, if you will. And then for every other token on the line, the only thing you can ever have is trailing trivia. And that table basically kind of explains that. So does that make sense to people logically? Oh, thank you so much. Frederick just said, you're right that you love having an engaged community. I want to reply with stating how much joy it gives me submitting PRs and watching you make sense of them live on stream. Thank you very much. I thought that was a thing that I think is the problem that everybody has, is when you submit a PR, it feels like a black box, right? You submit your work to somebody else, and then at some point they may or may not look at it, and you can't see when they do it, right? So very often that's also why I think we on our team try hard when people submit PRs to respond to them, and express in text form at least how we feel about the PR. And we have the luxury of having a great number of contributors in .NET, and in fact, just yesterday I was pulling some stats again, and it's kind of insane if you look at the number of PRs that emerge that are not from us, they're from the community, and it gives us a great sense of accomplishment that is beyond just the code, right? It's also the community around it. Very nice. Can a comment be attached to 2 nodes at the same time? No. So this model would still say, so in the syntax tree, a node, a token, or a trivia can only be contained in one thing. And that is also important if you think about how you want to navigate the tree later, right? So if you think of an IDE where you put your caret anywhere in the text, you want to be able to say, where's this guy? And if things are contained in multiple different trees, those answers are no longer well formed, right? Now it's like, well, and that's, generally speaking with trees is they're not graphs, right? So, if you did computer science, the difference between a tree and a graph is that in a tree, every node can only have one parent, right? So don't cross the stream, so to speak, right? And so, yes, it's a syntax tree, not a syntax graph. So you can only be contained in one element. Does that make sense? It's very hard to describe the PRs in English when it's not my mother language, my mother tongue. Yes, that is a problem that we all have, I think. I mean, I live in the US now for 10 years, so I probably do better than I used to before I came here, but it's certainly a problem that I think most of us, even at Microsoft, we have a decent amount of people that are non-Americans or non-English speaking people. So English is always a challenge. But the good news is there's always fun, right? We always make mistakes that sometimes are hilarious for native speakers. I still remember this when I did my first trip to London. We went to a restaurant, and in German, when you order something, you can say, I'll get a beefsteak, right? It doesn't sound very demanding. It sounds just very normal. But the problem is if you do a literal translation of the German words, there's what's it called? A homonym, I think, a word that sounds similar but means something different. And the German word for get is bekommen, which sounds very similar to become. But if you say, I become a beefsteak, not quite the point you want to communicate, I guess. Anyway, so let's talk about trivia again. So basically what I will do is I will create this class here, and then I will put it in our syntax tokens, and then we see how we fare with that. So let's put this guy here. And then we take it from there, I guess. So this guy we already have, so we would put this guy somewhere here. Of course, this guy needs to be sealed and public. So syntax kind would always be a trivia, right? So we already have this notion in our syntax tree here that we named things with the trivia suffix, which we only have those right now. Yeah. I think I need to reorder this for my own sanity. All right. And then probably we also want a function eventually on syntax facts is trivia, but right now we wouldn't use it for anything, so we don't need it. All right, so we need immutable collections. Yeah. So one thing we need to also think about is now the concept of spans. So we have this thing here called span, which is effectively the span that this syntax node, if you will, covers, which for a token is the actual length of the token. But for a regular syntax node, let's say I don't know, a for loop, for example, what should the span be? And the way we defined this, we said, well, it is literally the region from the first token to the last token, right? And so the way we just do, we say, well, each node must have children, otherwise it would be a token, right? And so we can say, well, give me the first element and the last element, and then just take the bounds, right? So logically, what this means is when we traverse the tree, we can actually do a fairly efficient tree traversal, right? Because we could say, given the position, where's the node, the closest node that contains that, right? And given that each node has a span, we can traverse the tree and effectively decide which if you have a collection of children, which child do you go into. You can basically do a binary search, right? So you can relatively easily traverse the tree, and computer science is too long ago, but I think it's a log n lookup, right? Because you don't have to traverse all the nodes, so it's not O(n), but it's also not O(1), so you need to probably look at more than one node, and the length is effectively the what's called the spine of the tree, like basically how deeply nested the tree is, and that's in a tree form, a logarithmic number. So it's O log n, I believe. And so in that sense, that's great. But now when we have trivia, well, what should the span be, right? Should the span be including or excluding the trivia? So if you ask for loop, for example, should leading whitespace be part of the span? Should trailing whitespace and trailing comments on the closing brace be part of that? Yes or no, right? And the answer is, well, it depends on what you want to do, right? If you want to do syntax highlighting, then, well, yes, because comments need to be rendered differently. If you just want to find the node, then the answer is usually no, right? For semantic analysis, right? So basically, long story short, is you probably need two different spans. Now we need span and another span that includes everything we have. And that one we call full span. It's the same thing that Roslyn does. And so it's effectively the exact same thing. We just define this guy over the full span now. And that's fine. And now the syntax token is basically the only part that has to override this. And would have to say, well, span is this. And then full span. I mean, at this point, the arrow is a little bit weird. So this is basically saying leading trivia. And then we say its position. Otherwise, good point. We probably need a span in this guy as well. Public span, sorry, text span, span. And then we say this is span dot start. And then end would be the same thing, right? End is either you know what? This is actually very weird to read. Oh yeah, first or default. This would be span. And then we can say end span is trailing trivia first or default. First, not first, of course, would be last or default. And then we can say return text span from bounds, start span, end span, end. What exactly is your problem? Oh. Default if empty first. I think I always make this mistake. Last. And then probably a semicolon here helps. And what's your problem here? What? Immutable array does not contain a definition for default if empty, and the best extension method overload on parallel enumerable default if empty requires a receiver of type parallel query. What have I done? How is this ambiguous? I see what the problem is. I think at this point, honestly, the other one would be easier to read. I thought it's easier for us to just express this over that, but nah. Once you have to like chain like 4 link methods together, you are worse off. So trailing trivia, if it's 0, then it's I guess span start, span end, and then we say this is trailing trivia. Lost end. And then just for consistency, and then we can say return text bounds start end. Yeah, that makes sense to me. Anyone knows how to trigger VS Code IntelliSense to show up function parameters I have to delete and retype a character? That's a good question. Parameter. Trigger parameter hints. I guess this is the command, and yeah, it doesn't seem like it's bound to any keyboard shortcut. I think in Visual Studio it's like Control-Shift-P or something. Or was it that? Yeah, something like that. Yeah, I usually do that like a caveman. Alright, so now we have that guy. That's fine. Our syntax token, we should probably put this into its own file. And then, well, here's a great example of what Roslyn, oopsie daisy. Yeah, so what just happened here when I extracted the file, you saw a blank space here, or a blank line here. That is the problem with why trivia is hard in the compiler, or in the IDE, I guess. So let's create a constructor here. And we take a syntax kind. Oh, let's just mirror how the token works. We take kind text. Position. Probably. Yeah. Yeah, you probably also need to take this in. So that's the other thing we need to think about here is our parenting structure. We probably want to take a syntax tree as well. I think right now we don't do that, but ultimately we want every node in the tree to know its parent. And given that we have to construct the tree immutably, we can't pass in the parent yet. So the way it works is we pass in the syntax tree, and then we can ask the syntax tree later, lazily build a dictionary from child to parent, and then you can ask this way. But for now, let's just do this. And then it gets us close to where we need to be. Yeah, so now position. We can probably do that, right? Of course, there's no override. Close enough. And now we have to change our lexer to actually get these guys in. So the way we want to do this is, right now we have this giant lex method that basically does everything. And we will largely keep this guy, but we will rename this guy. So we will have a lex method, and then this is a private method now, and we call this read token. And it will not actually return anything, it will be void. Then all of this stuff goes into the token method. So we will say read token. And now the structure is pretty much the same for all of our stuff here. So generally speaking, we have these read methods. And what these read methods do is they effectively advance the position. And they also will generally assign the kind, right? So start is taken care of by us, and then kind value is effectively assigned by the read methods. So what we will do is we will say we will have a method called read whoopsie daisy, read trivia that we call, and then we say leading is true, and then we will do another pass where we say leading is false. And then the idea is there's a collection with our trivia. So effectively we have one shared builder for that. Immutable array. Really? Immutable array. That's kind of annoying. Oh yeah, it's immutable array of syntax trivia, I think. Builder. Trivia builder. Yeah, I can't do that, right? I have to say immutable array. Create builder. So far so good. Now we have this guy. Now the idea would be that these guys will update them. So we would say leading trivia would be trivia builder to immutable. Trailing trivia oopsie daisy here, and then we would have to say var token kind is kind, token start is position, something like that. I'm not sure I like the flow entirely, but that's probably have to set start to position now. No, actually that's done in each method individually, so that's fine. Yeah, we would have to say token length is position minus start. That works. Right. And now we can say, okay, this would be token text for token kind. And that would be token length. And then we can say leading trivia, trading trivia. So let's add these two guys. What do you mean? Why would you add object? Oh, you wouldn't add object, you just add, that's just the existing one, trading trivia. And then these guys are just here, we would just say they assign. These guys. Something like that. Control Shift Space. That does not do anything for me. Comment for legs shall legs. Here there be dragons. It's not that bad. It's just a switch statement. Token start. Token start instead of underscore start. Where would that be? So token start would be this one here, right? So this should be right. So this looks right to me. So let's do read trivia. Let's move this down here. So logically what this would do is very similar to this guy here. We should probably set kind syntax token bad token trivia. And we should probably set text to null, not text probably, value to null. And then what is this other stuff here? Yeah, on second thought though, we should probably do this here instead because we want them all to do that. So this guy basically sets the, yeah, same thing here. So we want to do exactly what this guy does. And then effectively we have the same switch statement as well. And then effectively we just have to extract the thing that deals with whitespace, which in our case, this is end of file. We do need these guys. Read single line comment, multi-line comment. Otherwise we are done. So this would be a loop as well. It would say yes, we would say while var done equals false. It's one of those things that I hate in the C language, is that break is used both to terminate case labels as well as loops, which makes for really ugly code. In fact, I don't even understand why they went with this crazy design to demand a break and otherwise fall through. Like, that seems like falling through is not that common. Like what C# did with goto was much, much better in my opinion. So break should have never been required in the first place here. In that case, we set done to true. And then, of course, we have our favorites. Something like that. Let's see whether anything else is here that looks like white space. So enter file plus minus star. So these guys can no longer occur. So it's just this now. Parentheses, colon, comma, tilde. Head, ampersand, or equals not bang less blah. Okay, strings, numbers. Yeah, we should probably do these guys here, right? So we can delete this one. And we should be able to delete that one. Yeah. So the reason we do this here, that we handle these guys before we call this guy, this method you call here is not super, super expensive, but more expensive than a switch. And so these are by far the most common characters that occur as white space. And if we cared, we can add more to it. Yeah, so now we have to do leading, right? So logically, let's break this apart and say, well, if this is leading, no, if it is not leading, if it's trailing, then we are also done. Right, because we said we only read trailing trivia that is still on the same line. So that means if we're trailing, then we're done. I think this is it. Unless I made a ginormous mistake somewhere. Tabs are good, but Immo doesn't like it. No, I'm not a fan of tabs. I understand the philosophical reason why tabs might be the superior indentation method, but in my experience, having worked with tabs in various code bases, it never works well. Like, yes, editors are supposed to differentiate between tabs and spaces, and you would use here was an example for this, right? If you would wrap things like this, right? If you would have another argument here, foo, right, int x, right? You would say, well, up until here I use tabs, and then from here on I use spaces, right? Because I want to align these guys here, right? And then you have like tabs here, and then you have spaces here, right? Because you use spaces for indentation and tabs for indentation and spaces for alignment, but it never works well. And then half the time when you commit changes, you have to fuck with tabs, and I mean it's bad enough that people have to get line breaks right with Git, but it's not worth it. Anyway, all right. So what do we have here? So we now have this guy that should do what we want. So what does our parser do? So our parser has to right, our parser basically manufactures a token, in which case we would say this is a mutable array of syntax trivia empty Okay, so now the only thing we have to do here is nothing constructs our trivia yet. We only read it. So where would that be? Probably here, right? Because that's our... We clearly go here once. So we would say, well, var trivia is new syntax trivia. The kind is the kind. Which kind of also means this stuff should really be here at the beginning of the loop. The position would be start. Oh yeah, sorry. This is the tree. Kind, start, and then text. Fine, be like this. Var length is position minus start. That means text is I see. Thought we did something more clever there, but we did not. Text, all right. And then this is length. And then we just say trivia builder add trivia. Okay. And then the only thing we need to do here is clear this guy. Otherwise bad things will happen. All right, that seems reasonable. So now I think the one thing we want to change here is we have our somewhere we have our thingy that renders the node, right? Our pretty printer. So probably in here we want to do that, right? All right, so now we can say for each var trivia in T leading trivia. Writer, right. And then just trivia kind. Not sure that's the best way to do it. Let's try this for now. And trading trivia. And let's spell this out, otherwise T is ambiguous here. No, let's not do that. Yeah, that's what I... This code here is not super well written because it's the control flow is a bit crazy. But fine, we like that. So we can do this here. We can say, so this is our indentation. What is marker? I see. All right, so that's fine. Yeah, this gets complicated now because we now have to select the correct marker, right? If we just print, so basically the question is how do we print them in the first place, right? If we print them as children in the token, then that gets annoying. If we print them, yeah, if we print them as children, then it gets worse. If you print them as siblings, then it is not quite as bad, I guess. But that also means that last, yeah, I guess it's not that bad. We just have to say, yeah, so let's just print this here for now. Actually, I still have it in clipboard, I think, right? So if node is syntax token let's just do this here. Var token equals node as syn token, right? And then we can say if I guess that's fine. If token is not null and token value is not null, token not value. And then we can say if token is not null, then print the token and print the tokens leading trivia. Seems reasonable. Except there should be token. I mean, it's right now not pretty, but works for our purposes. And then we just do the same thing here with trailing. Of course, we need to also include indent and all of that other stuff, right? So there's, what is that? Writer, right, indent. something like that. Yeah, trees are annoying to print, I can tell you that. And then, of course, it's not the only thing we need to do. We also need to print the marker, which in our case would always be this guy. All right, by definition, so var has trailing trivia, token is not null, and token trailing any. Okay, so then we can say if not has trailing trivia and is the last one, then we take this one, otherwise we take this one. And this would be the token marker. Ay, ay, ay. And then we can say writer, write trivia marker. Is last trailing trivia. Trivia equals token trailing trivia last. I mean, not ugly at all, but I guess gets the job done. I guess that's a good point. While not done, maybe. Moment of truth. Indeed. Gee, my computer is really, really slow. How bad is my CPU utilization? Is it that bad with streaming now? Yeah, OBS is keeping the GPU busy, but CPU is actually fairly fine. So what's going on here? Why does this take so long? I guess that usually means you have an indefinite loop somewhere, would be my guess. Something doesn't terminate, which means our process should have, yeah, this guy runs in 11%, which probably means one core is busy 100%. So what is happening here? So we said while not done. Done true. Yes. There's this very obvious terminator here that we have to handle, which is EOF. Otherwise, bad things will happen. But I guess that should still handle here, right? Unless that's considered white space. But it should also mean if we really have a 2-minute loop, we should probably have memory allocation issues, because you would grow that array forever, which we don't. So we must be in some loop somewhere that doesn't allocate. That kind of means it can't be this loop here. That is strange. Let's try this again. Maybe that fixes it already, but attach debugger to running process. Yes. I think that's the next step. I know I have to cheat because I have honestly no idea how to do this with VS Code. So also I haven't used VS in a while. Feeling nostalgic. Let's build into VS Code. All right, let's give it a shot then. Attach. All right, .NET exe is this guy here. Let's set a breakpoint. See what happens. But I guess I have to do that. So we are clearly running. So what is going on? Main thread. No. So where are you? That's not really helpful, is it? Maybe I attached to the wrong process. Let's try. Attach. Jesus, I don't even remember the shortcut. It hasn't been that long. CPU would be helpful here. But I think it's probably going to be... Did I just kill the process? Hopefully not. There we go. That will be the one. Well, yes, fair enough. Yeah, updating the S now is not time to do that. So that is a lot more helpful. So they are all waiting on something. What? I am confused now. Why would that be? Okay, clearly there's something weird going on here. Let's try the other way then. Let's try to actually set a breakpoint here, and let's just run the guy and see what ends up happening. I mean, how hard can it be? We have done harder things on the stream, I think. Okay, so far so good. Now let's go to the Lexer. And let's set a breakpoint in Lex. Alright, so let's do a single step. Okay, this worked. Leading trivia. So the question is, what do we have actually in our text buffer here? So we have quite a bit of text. Alright, that's fine. Let's actually close this guy here. Alright, so okay, we don't use token value, that might be a problem. So we have leading, we have trailing, bad token trivia. Okay, that makes sense because we put that might actually be why our stuff doesn't terminate, but that would mean that our parser does not advance the way it should, which is also bad. And then this should be token start while we're at it. So let's see whether this fixed the problem. Let's run this guy again. Something tells me that it already fixed the problem. Why is this not building forever? Something is not right here. Okay, the build failed because the process never terminated. That's why the build took forever, because it waited for the process to terminate. Alright, CSC is busy building its stuff. Okay, build succeeded. Okay, are we getting to this line ever? Oh yeah, it didn't terminate because we never got our enter file token. but we were also done, so that's why I didn't allocate. This guy would just spin forever and just return the same thing over and over again and still not terminate. I think this should fix the problem. Yes, it did. Interesting. Lex here, Lex. Substring. Line 62. Yes, that is correct, because it is token start. Seems fine now. All right. Reset. Show tree, I think, right? And then we can say space space function. Yeah, so there's one bug that we have right now. As you can see now, if I have leading spaces, weird things are happening because when we print the line back, we iterate over the tokens, and that does not include the leading and trailing trivia collections. But hopefully that's just an issue with the UI here. So we say so this is what we are printing right now. Whitespace trivia, bad token trivia, identifier token, bad token trivia, bad token trivia, bad token trivia. So it seems like as far as trivia is concerned, we don't really get our trivia in. Which might be an issue here, right? So we set this to bad token trivia, and then we use the kind here, so that kind of makes me believe this guy. No, this guy sets whitespace token trivia. Okay, let's reorder these guys in a way that feels sensible. Okay. All right, so this guy whitespace sets whitespace trivia. Single line sets single line. And then this guy says multi-line, it says multi-line. So that's also fine. So why would that not work? So we said start to position, we say we are bad value, and then this guy runs. Oh, I think I know what the problem is. So the problem is right now, it's all fine when we did anything, right? If we haven't consumed anything though, then we shouldn't do that. So we probably should say something like for starters. That's one problem. The other problem that we have now is when we print this stuff, we need to flatten this guy. So where's this render line? Render line, that guy here. So basically what we do is we say parse tokens, and then we put the tokens in. That is a bit too simplistic now, because our tokens are not the representation of the input anymore, right? Because it's a combination of tokens and trivia. So one way we can do this is we can extract this guy into something else and effectively have a representation that unifies tokens and trivia into something sensible. And I think what I want to do is I want to kind of do it the right way. Yeah, I think what I will do is I will, instead of parsing tokens here, I will literally parse the entire thing as a syntax tree, because now we can, right? Our syntax tree will now contain all of the stuff. And then what I will do is I will walk the syntax tree, including trivia, and will return spans over that. And then I think what I will do is I will call this classified span or something. So let's actually think about how syntax highlighting should work in general. Let's build a separate type here. Let's call this classifier syntax. Yeah, classifier is fine. And then we have something like classified span, which would take text span, and then we say we have a classification here, enum classification, right? Which is basically how we want to render this. And we have what colors are we actually supporting right now? Render line. What do we handle? We handle keyword, identifier, number, string, comments, right? So let's have those as classification entries here. So that would be identifier, keyword, number, string, comment, and then I don't know, text is the default. And then we say that this is a classification. Right, and then let's say we have a public static. Let's say INumerable for now, because I have no idea how I write this yet. Classified span. Classify, and I take in a syntax tree. And let's say a span that I want to classify. I think what I want to do is I want to say this is an immutable array of classified span. Result, and we say is immutable array create builder for classified span. And then we just say classify for syntax tree dot root span and result, and then we say return result to immutable. And then we just say syntax node. And then I can say for each var child in node children, if child span, actually full span, excuse me, overlaps with span, I guess we say this if node full span overlaps with span. So if that's not the case, then we bail. Otherwise we say classify the child for the span and the result. Something like that. And then we can say if node is syntax token, then we say classify trivia for each var t and token leading trivia, classify trivia for span and result, trailing trivia, trailing, yeah, something like that. And then we can say classify token for token, yeah, I think something like this is probably the right thing. Yeah, this is going to be a bit messy, but that's fine. So I think what I want to do is I want to move this guy here. I want to move this guy here. Makes it a bit more logical where the tree structure is actually happening. So logically classification only happens on tokens, right? So there's no classify node, I guess. Well, unless we make that this guy here, right? And yeah, so basically, so what would this guy do? So this is trivia, right? Trivia. add classification for trivia kind, trivia span, and result. Element kind. Sorry, this would be element span. So what is happening here? Why do these pop-ups happen? I don't know. I should read them at some point. All right, so this is basically our thing that actually does the classification, and then this guy goes here. And this would be token kind, token span. Right, not full span here, because we only want to take the token itself. And the result, right? And then this guy is also where we do the trimming. So what is the logic that we used? So we would do this. We would say element start right, element span and then this is the actual span. We call this element end adjusted span, I guess. Adjusted start, adjusted end. Right, and then we just say var classification is get classification for element kind. And then we just say result, yeah, var classification, classified span is new, classified span for adjusted span, and the classification that we just computed. And then we say result at classification. Almost. And now this can be a very simple switch statement. Although I say that, but more like this. Then we say return classification keyword. Identifier, number, string, comment, text. I think I've reached the point where I want to edit here again because I can't actually type classification. Nice. So much nicer. All right, element. So we call this kind. Nice. All right, so instead of doing all of this then, so first of all, the render state is not much simpler. The render state is our syntax tree. Syntax tree. Right, no longer tokens. And then we just say syntax tree parse text, I guess. And we call this syntax tree. And then we just say classified spans is classifier, classify the render state syntax tree for the line span. Right? And now we can say classified span. No longer have to do this because we already handled that. We have to do this in order to get the thingy here. And then basically we can replace those with a switch statement. So we say switch classified span classification. Case classification. Did I misspell this? Classify. Really? I can't spell it for the life of me. Yes, I did misspell it. That is sad. Do we need... Oh, that's funny. So the render state is now even similar. We don't need the render state at all. So let's get rid of the render state. We just say syntax tree. Syntax tree. So if the state is null, then we say syntax tree is syntax tree.parse on the text. And then we say state is... No, actually, we do this. Otherwise, we say it is this guy here, and then we just say that. All right, so something like that. Identifier, number, strings, comments in green, and text is dark gray. Just to make sure we handle all the cases. Nice, we don't need that either. And then we can just say text. Or I should say classified text. Right, syntax highlighting is now much nicer. Now the only thing is you have to decide where to put these guys here, because they logically don't belong in the REPL either, but all right. So let's see what ends up happening now. All right. Classical problem. I have this guy open already. That's why nothing works. That's the downside of using multiple IDs at the same time. All right, so here we go. All right, so here's one problem. Our hashtags don't show up anymore, which makes me believe that we don't put everything in the tree yet. But if I say 3 plus 3, that works. If I type a comment, that works. Or not for that matter. Where are we crashing? Render line in line 47. That means the span we return is wrong. That seems hard to believe. Is the bug here? I don't think so. Basically, the intent here is we are adjusting the span to match the span that we were passed in. So we're saying the adjusted start is the maximum of element start and span start. And the adjusted end is the minimum of the element end and the span end. And then we say the adjusted span is from bounds start end. And that's the thing we classify. It seems pretty straightforward, almost impossible to fuck that up. Then we say here, same thing, leading. So classified token, we say classification. That is let's make our life slightly easier here. This guy doesn't add anything really. Right. That seems also reasonable. So the bug is not here. That means the bug is in the Lexer, which is unfortunate. So what is the problem here? We have entered a line break. Length cannot be less than 0. That makes me think let's go to the Lexer. And see what ends up happening. Yeah, the history of the C# compiler is a history full of mysteries. Now, basically the idea of any compiler usually is you want to write the compiler in itself, because that means the compiler team is actually using the language. That's also called self-hosting or bootstrapping yourself. But of course, when you start a compiler, you can't write the compiler in itself yet because, well, you have not written a compiler yet. And so there's a sharp compiler was written in C++. I mean, not really C++, more C with classes, I guess. And then, yeah, I think, I don't know, 7 or 8 years ago, they rewrote the entire code base in C# and the VB compiler in VB. And the reason they did this was not just for, oh, we want to use the language ourselves. And that was part of the motivation, but the other big part of the motivation was the C++ compiler code base was too complex. And one of the problems is they wanted to expose the compiler to the IDE in a way where they can actually do meaningful stuff in the IDE, like, for example, syntax highlighting, refactorings, analyzers, and that sort of thing. And that became really hard because the compiler was really designed to be a batch compiler on the command line, right? It wasn't really, designed to be hosted in an IDE context. And I mean, they made it happen, of course, but one of the problems was that the compiler was full of mutable state, which in an IDE is not great because everything is asynchronous usually, because as you're typing, stuff is happening in the background. And so when they moved to Roslyn, or when they rewrote it in C#, they also made the whole thing immutable and made it much easier to actually do high-level stuff in it. And that's also why the namespace is code analysis and not compilers, because they expect most of the people that use Roslyn are not actually compiling, they're just using it to ask questions about the code. Anyway, so where are we here? So we are now reading trivia. So first of all, why is this guy running at all? I haven't typed anything yet. Oh, because it's we already have a submission, I guess. Okay, so let me reset this guy. Which ironically works. Okay. Test. Now I want to see what happens when I hit enter. All right, so leading should be true. All right, so now we have a look ahead of /, yes. We read a single line comment. We break. Length is what? 7. That makes sense. We get the text, which should be our comment. Yep. Create the trivia. We are not done. We set position to this. Now we find okay, now we find end of line. Okay, that's fine. Right. So length is not, yes, that makes sense. Token status position, read token. We had end of file. Yep. That's what you would expect. Token length should be 0. Yep. Token value should be null. Token kind is end of file. That all makes sense to me. All right. So now what does trading trivia do? We say we're done. Wait, don't do anything. We enter. So that means Siri, stop talking to me. So we now have leading trivia with one element. Token text should be null. Which should now be nothing. That makes sense. So enter file, token text, token rate, that all looks great. If the token is not trivia, enter file. That seems all fine. Okay, so now we are asked to tokenize again, and I guess this case we have the line break in it. not for that matter. So who asked here to parse? It's our syntax handler, and the syntax handler, okay, that's fine. So then, okay, so I think I moved past the crash. So I think there's probably the multiple parsers happening, and I hit F5 once, one time too much. Let's see the entry point here first. Yeah. That's right. All right. To make my life a little bit easier. Enter. All right. So that is fine. So this should be okay. Now we go. Now this is with the line break. Now let's see what ends up happening with the trivia. All right, so this one should be our single line comment. That's fine. Now we have EUF. Actually, now we have a line break. We read this one. Length is 2. The text is this guy. It's whitespace trivia. Okay. Now we're at EUF. Okay, so now we can probably ask this guy here what happens. So we had EUF, we break, we don't do anything. So that means leading has 2. Right? The single line comment and then the line break. Yep. And then trailing we have 0. Our token text is null. So token kind is EUF, token start is this, token text is this, token value is null. So that seems all reasonable. So what is blowing up? So now let's classify this puppy. We get 3 classified spans out of this. We have text from 5 to 3. Yeah, that's not working, right? So why do we get this guy? Let's move this guy back and let's see what ends up happening here. So we apparently I'm bad at debugging today. All right, so what is the node we're on? The node we're on is the compilation unit. I guess the easiest way to do it is we set a breakpoint here. Actually, here. And see what we get. So we're now standing on a single line comment trivia. The element span is 0 to 3. That makes sense. Now we're getting a whitespace trivia. The range is 3 to 5. All right, so this is an interesting case. So the element span is 3 to 5, and the span is 0 to 3, which means we should not have the element in it at all. That's right. So That's, I think I know what the problem is now. So this is add, should have done this. Extract method, that's what I wanted to do. So this is called classify trivia. So we have to, of course, have to pass this guy in here. This would be, yeah, I think we made our lives harder than it needs to be, I think. Probably should have just written this guy by hand. And we call this cern trivia. Trivia. So why save as? Do I hit the wrong keyboard shortcut? Must be. So, and now this is where this guy gets put. For consistency, we probably should have put it here as well, but given that tokens are nodes, this won't be a problem. And then we call this classified trivia. And then this guy would be span. I guess in this case it would be more like here, right? Token. Yeah, that makes sense to me now. I mean, we could also probably handle this guy here, which might be cleaner, because then we don't have to do all of these checks here. In which case you will be back to square one actually, but so if element span overlaps with span, so if they don't overlap, return. Yeah, that should fix the problem. TerraJobs, I only wanted to thank you for all the work you have done here. I had been thinking about writing my own compiler for a long time, but never really got it until I found your videos and streams. They were the learning material, the starting point I needed, and I've learned so incredibly much. Now I published the first little version of my very own language. Without you, this would have been possible. Thank you so much. That means a lot to me. Like, I think I was in the same position as everybody else, where it seems very daunting to write a compiler, and I solved my problem by mostly reading other people's compilers. But up until Roslyn, I think I've never seen a compiler that I liked architecturally. They always felt very messy, and that also contributed to my hesitance to actually do anything useful with it, because who wants to write a messy compiler, right? Nice. So now this works the way we expect it to. Or not, for that matter. So what happened here? We null reference in line 298. 298. What did I say? 298. Oh yeah, null is of course something that can happen in the tree. Actually, that's an interesting regression. Null shouldn't happen in this case because we are walking the tree generically. So I think this is indeed a problem in our generated code here. So what ends up happening is we have this thing now where we emit, let me show all files, where we emit this guy here. And normally for things where we wrote this thing by hand, we basically said, well, if things are null, they be now optional. We would say, if not null, return. And now we just blindly always do this here. So what is a good example? So function declaration, for example, right? So the type is optional, right? And so this guy might return null now. So unfortunately, we don't have nullable reference types yet, so I actually don't know what is supposed to be null and what's not. One simple fix is surrounding them all with null checks, but that seems excessive. I think that's something I should file a bug for, actually, now that I'm thinking about it. So let's do that. Issues. Syntax node get children should not return nulls. That's a regression we introduced when adding, when generating get children. Ideally, we'd use nullable reference types to know which ones can be null instead of blindly checking all. So for now, easiest solution for us here would be to handle this at the right level. So we can do this here, right? We can say apparently I'm really bad at editing right now. If node null or that should solve that problem. I should probably leave a comment. Hack node should never be null, but that's tracked by all right. So now I should be able to do sane things here. Function do it. Yeah, so no longer crash. Show tree, I think, right? So, okay, that's the same problem we have here now in our iterator. And yeah, this is of course not correct. Yeah, let's fix the output here because that one is a disaster right now. So clearly we want that to be somewhat reasonable. But before I do that, I think I want to move the classifier to a separate file. For the time being, I think leaving them in the REPL is fine. Ultimately, this is the kind of stuff that should go into a separate thing, for lack of a better word. I think I want to have its own project that that basically deals with IDE-like stuff. So for the time being, let's just at least get the namespace right. Minsk code analysis. I don't know what to call this yet. Authoring. Okay. So now let's actually introduce a new folder here. Right, these guys. And then, not that it matters, but like eventually they need to be public anyway. Might as well make them public now. Public, sealed. Okay, so then that's halfway decent. And then hopefully I can, who knows. I need debugging again. So now let's see what we want to do. We want to fix our pretty printer, right? And the syntax node. So that guy has the same problem, right? Because we are right now walking over all the nodes. So probably we have to do the same thing here. We say if node is null, bail. And then we say this is a hack. Node should never be null. But that's tracked by... That's right, we get intelligence now. Isn't that cool? Yeah, that is awesome. That's one of the reasons why I like VS Code. Alright, so this one is fine now. We should no longer crash, but now this one here is wrong, right? It is... It's is last trading, so it must be is last. And it must be the last trading trivia, right? Otherwise we're not the last element. And then the other thing is, I think our colors are messed up because we always want the marker to be dark gray, I think. Right, so that means we would say yeah, this guy is messy no matter what we do, so we might as well make it messy all the way. And then I think the question is, yeah, let's move this guy down here. And then we say this guy is, let's say dark green. Right, trivia should be green because it's comments, right? And then this guy already sets the color, I hope. Yes, so I think the only issue that we currently have is that we lose the hashtag, which I think is because we don't include bad tokens anywhere right now. The name classifier does not exist in the current context. What? How is that possible? Oh, because we changed names, but we did not add a using to it. That's fine. Yeah, the banned token thing we will also fix, which should be relatively straightforward. All right, so now let's see. Show tree. And then we can say test function do it and hello. All right, so we have single line comment trivia leading, whitespace leading, the function keyword, whitespace trivia trailing, identifier open parenthesis, close parenthesis. Then we have trailing whitespace trivia. Then our block statement happens. Right, so this is the line break here. Then we have an open brace, a line break, an expression statement. Huh. And this is where things get weird. So what happened to this whitespace here? And what happened to this whitespace here? So it seems like we're not visiting everything for some reason. So the funny thing though is this guy is dumping the tree, so this is not even visiting anything. So in other words, they're literally missing from the tree. That's a problem. That is slightly concerning. Oh, I see. I think the problem is that I have maybe bad syntax. Okay, this makes more sense now. So I think what ended up happening in the previous one is because we don't handle bad tokens, we dropped an entire thing on the floor, and that's why stuff doesn't make sense here. So, okay, we have leading, so we have the single line comment here, we have the white space here, which is the line break, we have the function keyword, we have the space, identify open parenthesis, close parenthesis, we have the trailing, which is the line break, block statement, open brace, line break, and then we have an expression statement with a call expression that starts with an identifier token. And again, this is weird here because we should have leading trivia for this line, for this here. And the close brace probably doesn't have trading trivia because I think the text literally ends here. I don't think we have a line break there. So that would make sense, but I don't understand why this is missing here. I think you're not breaking on new line and trailing trivia if there is white space before new line. I think you're right, Lucas. I think you are right. It's the other thing that so when we say reach trivia here, so this loop keeps going, and then I guess whitespace is this loop will basically do all of this. It's not wrong, but it's also not quite right. I think for simplicity, I think we want to not do that. You probably want to say something like switch current case. Read line break. I guess that's pretty much. Yeah, I guess let's do it the other way around. If current is not, and current is not any of those, no, actually I think a switch statement is better. It's like, let's just bite the bullet. And then we should probably do the same thing here. We should probably say yeah, we should probably say var done equals false. And then we can say while not done, switch current case yes, so that would be R and N default if char is whitespace current. Well, if it's not whitespace, then we say done equals true, else right? And then we introduce a different method that we call line break. So the thing with line breaks is, I think we want them as a separate trivia because so many things want to deal with line breaks. And then the only thing that's tricky here is let's call this line break trivia. Line break trivia, which we don't have yet, but we can add this. Either one works. So we have to say if, so there's basically multiple cases, right? There is just this one, there's just this one, and then there is CRLF, right? So if current is CR and look ahead equals then we say position plus equals 2, else position plus plus. Something like this. Okay, now let's see where we handle this guy. So this would be line break. Okay. Let's do this again. Oh, I love it. The chat is now debating porting. All right, so now let's paste this guy in. Oh, beautiful. What happened here with... This is not good. I think there might be an issue with my console window where, for some reason, copy paste doesn't do what I want. I want show tree first. So now things make a lot more sense. So we have a single line comment, a line break, a white space, a line break, indentation, line break, indentation, identifier, line break, close. That is nice. All right, so I call this one already a success. Now the thing we need to handle in the parser is this here. So is trivia here? We'll never see any of these guys, right? So the question is, how do we want to handle these guys? Because right now bad tokens are actually produced as tokens, not as trivia, even though the thing is called trivia, because we effectively say everything that's unhandled by the lexer is an error. So I can't do this in read trivia because that would preempt, I would now have to effectively know upfront what all the characters are that or character combinations, I should say, that the read token method handles, which I don't know. So I can't actually read it as trivia there. So we have two options. We can either say we return this as I think the way I want to do this is I want to do, so I don't think we want to have bad token trivia. I think the way we will do this is we say there's a bad token, but that's not trivia. And then, so the lexer, so where do we put this token? So I think in the long run we need a notion for this anyway. it's not great, but like let's have this concept of skipped text trivia, which effectively everything that we want to funnel through, we can funnel through now. So that's basically the quick fix. And then syntax facts. Where is this trivia? That would say skipped text trivia. And of course our line break trivia. Right? Nice. So that is fine. Now the question is, in the parser, that's not the check we should be doing anymore because this can never occur right now, right? So this would never trigger. So we basically have to filter out our skipped text or our bad tokens. So here's what we will do. We will say if token kind is syntax kind bad token, bad tokens, new list syntax token. So first let's say we say token, we say bad tokens add token. Else okay, if bad tokens any, then we will basically say var leading trivia is token leading trivia to builder, and then we say for each var bad token in bad tokens, and then we say bad tokens clear, right? And then we say token is new syntax token for token.syntax tree, token.kind, token.position, token.text, token.value, right? Basically everything we had. And then we say trivia is leading trivia to immutable, otherwise to say token.trailing trivia. And then here we just say trivia is new syntax trivia for do we know the syntax tree here? Yeah, syntax tree. Not that it matters, but and then we say the kind is syntax kind skipped text trivia, position is token position, and token.text. Right, and then we say leading trivia. right? So the idea is basically we convert those as trivia that we insert back into the tree. So the problem that we now have, you also have to insert the entirety of this guy. So we would have to say for each var leading trivia in bad token leading trivia, we would have to do that too, right? We would say that it would be this guy. And that would be trailing trivia. Right? Right. Let's see whether this works. Typo in skip text trivia. Why am I not surprised? Skipped text trivia. Yeah, don't want to save this guy. God, you're still booting. All right. That's not good. So something is not working the way we want. There's too much stuff going on. And I wonder what that is. So let's see whether we can... Yeah, I can't see these guys because they are not printed at the time I'm editing them. So leading trivia. Leading trivia to builder. We copy the entire token. Also very important, we clear this guy. Then we add the token. So if it's a bad token, we just say add it to the bad tokens. We would certainly not drop it on the floor because we always have one token at the very end, which is our EOF. So we're guaranteed that eventually we'll hit this code path here. So if we have bad tokens, so if we don't have bad tokens, then we just add the token directly. But if we have bad tokens, then we say, okay, give me the leading trivia, make me a builder, go over all the bad tokens. For each of the bad tokens, go over the leading trivia, insert the leading trivia there, insert a trivia for the token text itself, leading trivia insert at that position, and then go over the trailing and do the same thing. It seems reasonable, so why would you not? Why would that not work? I'm somewhat confused. All right, so let me think about this for a moment. So we have clearly some duplication here, as far as I can tell. So if I say function, that's fine. That's also fine. Also fine. Okay, so now if I say hashtag E, Oh, I'm an idiot. Yes, of course. It's bad token position, bad token text. Come on, Chad. You should have seen that. Yeah. Well, the way Roslyn does it is different. And the way Roslyn does it, it has this notion of structured trivia, but I'm somewhat hesitant to go all the way on that one. Okay, so this makes a lot more sense now. I can actually type stuff here, so I can, what do we do? Show tree. And how do I force this guy? Like this, right? Yes, so now we can see that we have a block statement, right? An open brace, line break trivia. Then we're trying to parse an expression statement with a name expression. We have whitespace trivia. We have skip text trivia, which is our pound sign. We have the identifier token, which is CLS. And we have a line break. And then we just report this error here. So that's nice now. So basically, our syntax tree contains these guys as well. There's only one issue that we still have, which I think for now I will not solve. Even skip text trivia, I think we probably have to eventually bite the bullet, and instead of doing what I'm doing here, which is just expanding all the trivia, is actually have skipped token trivia and actually have the tokens themselves as children. Reason being that that's cleaner. So in the parser we have this, if we search for skip, right? So here's an example where we skip a token. And so in that case, we drop the token on the floor. So we would have to make sure that we add this token to the next token effectively. Which I'm not entirely sure how I want to do this. But that's the idea, right? All right. But I think for now, I'm actually quite happy with what we have achieved. Here's our read trivia stuff. Any questions so far? Otherwise, I think I'll call it a day. Does it make sense to split whitespace trivia into alignment and indentation trivia? I don't think I would. Do you mean like tabs versus spaces, or what's the question there? Because to me, whitespace, I mean, line breaks are interesting because line breaks are just so pervasive, but like within a line, Like I think C# already supports like a gazillion different whitespace in Unicode. There's a ton of those, like horizontal tabs, what's another one, vertical tab or whatever. And I don't think we care. We just care it's a line break versus anything else. Classification. So classification. That seems fine, no? I guess it's the commit message that is messed up. No, I don't see it. The property name. Oh, yes. Also, wasn't there supposed to be syntax highlight? Like, didn't I have? I think I had. Or did I disable this at some point? Let me check. Spell. Sure. Enable spell checking language. Yes, it is enabled for that language. So that should have meant we should have gotten squiggles for these guys. Are we getting them now? No, we do not. Well, it is what it is. I'm not sure what that is. Classification. That took us longer than I was hoping for, but again, it is what it is. And I might actually have a meeting now. Let me actually see. I do, but I can be late to that one. Yeah, that's probably Visual Studio sitting on the file. Which is fine, we can close that now. Okay, now I'm actually doing a full text search. Here's another one. Classification. Okay, parameter name. Yeah, all right, so now we should have it, right? Of course, now we have test failures. Yeah, we have a lot of them because that's the token combinatorics. So there's one bug somewhere, and now it causes a ton of stuff. So I'm curious what that one is. I see. Okay, I think I know what the problem is. Get token pairs. So one thing we do here is in separators, we said number token, identifier token. Okay, whitespace trivia. This would be now line break trivia. Line break trivia. That probably already fixes that. I might have fixed it, But we may not have fixed it all, and now we have other errors. Which is funny. So this guy seems right. So line break trivia with separator text. Expected 3, actual 2. Interesting. So when we parse a break keyword, followed by a line break, followed by... Oh yes, because we do trivia collapse. That's a good point. That's a good point. So yes, we probably have to say in the assert method has to change. So basically we have separators here, which now means they are available as trivia. So we can either do this, which means we don't care, which might be problematic for other reasons, but this should at least fix the asserts. But we should probably also assert that it's either trailing or leading. Is there any case where it would be leading? It shouldn't, right? Because even if it's a line break, the line break still... Yeah, it probably works. Let me first check whether that actually works. Okay, that solved most of the bugs. So now we have 6 breaks. What are they? Right, so now that, yes, so basically we can't lex separators anymore as tokens. So the method is always the same method probably, right? It is lex token, lex token, lex token, yes. So lex token get token data, and so this guy basically says give me all the tokens including the separators. What did I just do? I did something stupid. So get separators is called by this guy. Tested token kinds. And by this guy. So yeah, I think we probably have to do this. We have to remove this guy here because that's no longer workable. Because now these things are trivia. And trivia works differently. We can probably do this. Get separator data. And that would be get separators. And then instead of saying lexis token, we say separator. So we expect a single token. Does this include the OF token? Probably not. Yeah, we probably have to say we probably have to include the UF token now, otherwise bad things will happen. How do we do this? We say if token kind is end of file is syntax kind end of file token break, but we should always include the token. If that makes sense. Then basically every single time we do parse tokens, we probably now have to be very careful that we don't so where's this guy being used? Yeah. Maybe I should just take an argument. So what do we have? We have parse tokens. Who's using this guy? Yeah, this is going to be annoying. Can I remove this here? I probably can, right? I can probably say token. Yeah, that is also not great. I don't like that. So basically we can either decide that we can have two methods now, parse tokens and parse tokens with EOF or something. I have a parameter, but then yeah, screw it. Let's do the parameter. That's probably cleaner. We'll include end of file false, because for the most part we don't care. And I guess, yeah, that's what I was thinking. I probably have to move this guy here, unfortunately. Not great, but does that. And then we say Lexis, what is this? Lexis separator. And then I think here we have to channel this guy through. Of course, we have to say this guy and this guy. Right, and then this is the actual one. A little bit messy. I don't think I like how that looks now, but again, we can probably help ourselves here eventually. And then we say So if token kind is not syntax kind dot end of file token or include end of file. All right, and now here we can say parse tokens, and then we say include end of file true. And then I can say var trivia should be assert single token trading trivia. Yeah, it works somewhat. Member data must reference a public member. Fine, be like that. What happened? Oh, sorry, referenced the wrong method. Okay, so first of all, theory method with separator does not use parameter separator kind. True. Took the shortcut there. Lexa Lexa separator line break fail. Okay. Lexa Lexa separator. Separator. Alright, so the collection contains 0 matching elements instead of 1. Yeah, because it's not trading, it's leading, of course. Duh. I mean, you can kind of see the complexity of trivia now because there is a nuance, right? You have to know where stuff lives. And that's the unfortunate side of saying the syntax tree contains white spaces and comments. Really? No, I'm confused. So white space trivia, text blank. The collection contains 0 matching elements instead of 1. So which one blows up? Line 61. Oh, I don't even have a token. Okay, that's a problem. Really, how is that possible? We said parse tokens end of file. Okay, we need to plug this guy through, right? Include end of file, include end of file. Okay, we have a parameter here, parameter there, parameter there. Yeah. It helps to use the parameter you passed in. That's an old trick I've learned. Nice. All right, so now let's try to tackle this warning here. This is 85 right here. So, oh, not there, right here. So basically what needs to happen here is we have to say var separator should be tokens 0 trailing single. Actually, no. We should do it like that. And then we should assert that separator text is separator.text. And this is separator.kind. A separator kind. I think. Okay, cool. So stuff works the way we expect it to. Yeah, while these tests are annoying to fix when they fail, they give us a lot of confidence that we didn't break something very fundamental. And I think that's the reason people use compiler generators usually, or parser generators, because they don't want to deal with that. But I find the amount of control we have here quite empowering, because it means we can do whatever the heck we desire, and there's no crazy framework we have to learn or whatever. It's just all good old code, and the code is not complicated usually, right? So all stuff we should be able to handle. You have a spelling error in the member data attribute. Okay, I misread. Separator is a weird word both for reading and writing. Yes, I have a Spotify plugin for VS Code, which I actually don't use at all. Like the music you're listening to right now doesn't come from Spotify. It comes from a service called Pretzel, which also comments like crazy in the chat right now. What I like about Pretzel though is that is music that is, you know, given to you in such a way that you can use it on the stream without getting copyright strikes. I've also configured it to be YouTube friendly, so you also can upload the video data to YouTube and don't get copyright strikes there either. But regardless of that, I'm actually listening to Pretzel more or less full time now, even outside the stream, because they have a nice station. And it's actually quite, like the music is really nice for background, and they have multiple stations. You can select no singing basically, so that you only hear instrumental stuff. And I like it a lot. And yeah, now that I have my Stream Deck here, I'm also not using any UI usually to advance any tracks. So, but it's a cool plugin. If you use Spotify, it's nice because it shows you in the status bar basically what the song is. You can skip the song right from there, and it's nicer than to mess around with a media player. It's called Brezen, not Pretzel. Well, yeah, maybe. Anyway, so this was all I had for today. So it took us 3 hours, which normally my stream is supposed to be 2 hours long. But this is what you get when you, I guess, make stuff up as you go. Sometimes it takes longer than you expect. But I'm actually quite happy with the outcome. So now we're at the point where we have trivia in our syntax tree. So the one thing we don't have yet, and probably I should file a bug for that as well, is skipped tokens should be what did we say? Skip tokens should be part of the syntax tree. When the parser decides to skip tokens, we should make sure that the tokens are still recorded in the syntax tree. Otherwise, syntax highlighting won't work. Yeah, let me just label things so that it makes sense for us. I know you can't see it, but it's just me filing bugs. So basically now we're at the point where, you know, comments are supported, comments are in the tree. We actually have already our first, what Microsoft folks call language service, which is our, you know, syntax highlighting service. So basically, if somebody can pass a syntax tree and ask for classifications, and then we give you back effectively a relatively nice data structure that just tells you where things, where spans are, and that thing also handles cutting off spans if you do line-based syntax highlighting, like what we do in our REPL. So that's already fairly nice, I think. Yeah, I think we need to think about what we do next week, I guess. Oh, sorry, Friday. See us Friday, right? I'm leaning towards null reference types. Chat can tell me whether that's a good or a bad idea. And then, yeah, I hope I see you on Friday. That's all I had. All the best. See you later.